the fund. The work team is made up of engineer Luis Fernando Martínez Castillo, Silvio Antonio Torres Luna, and Margarita María Muñoz Giraldo. The objective of the project is to help people in rural areas who do not have access to drinking water. According to the World Health Organization, drinking non-potable water increases the transmission of the diseases such as diarrhea, cholera, dysentery, typhoid, polio, among others. The product is a water purification and filtration system that seeks improve its quality until it is fit for human consumption. The reason for the project is motivated by the idea of guaranteeing access to water suitable for human consumption, reducing the number of sick people and the mortality rate caused by contaminants.
About its construction. To build this product, we need 5 models with a capacity of 10 gallons each. They are connected with PVC accessories. In addition, they are organized in descending order to identify the flow of the water. Each model contains minerals that are easy to get. It has an inlet mixer and an outlet tap to the final storage module. The entire structure is supported by a metal base that provides greater stability to the system. The image of the slide was the initial sketch, and from this sketch we start for the final design. The system will be built considering the following specifications. The first model in descending order. It was arranged to carry out water clarification processes supported by alum stone and considering a rapid mixing and subsequent sedimentation of the flux formed by the coagulation-flocculation process. In this part, a manual metal mixer with trapezoidal blades was placed to help complete the rapid mixing of water with alum. In the second model, there is a base made of fine sand with an effective size between 0.3 and 0.45 millimeters, a uniformity coefficient of less than or equal to 2, and a height of 26 centimeters. In the third model, a fine sand base with the same characteristics as the second model and a height of 14 centimeters was arranged, followed by a medium-sized coarse gravel base 7 to 8 centimeters in diameter and a height of 12 centimeters. In the fourth model, a bed of activated carbon in granular form was placed 5 centimeters high, followed by a layer of pumice stone cut unevenly at the height of 5 centimeters, based on the slow sand filter. Then a layer of coarse sand of 10 centimeters height with an effective size between 0.9 and 1.1 millimeters and a uniformity coefficient greater than or equal to 3 was placed. Finally, a 6 centimeters fine gravel bed was located with a size between 2.5 to 3 centimeters in diameter. As in the Tan 3, each bed was separated with material. The last model stores the filtered water and it has a glass that will be in charge of doing the last purification process through ultraviolet rays. The function of the glass is to filter sunlight, allowing only UV rays to pass through, and this is the innovative part of our project. And now here we can see the 3D model of the project. This is the final result.
The results. The test developed to check the efficiency of the filtration system were carried out for 2 weeks. The first result is the total coliform reduction. The system obtained a decrease in the contamination of the water. The contamination is given by a group of bacterial species such as Citrobacteria, Enterobacter, Klebsiella, and Escherichia coli by 99%. Before entering the module, what has the glass that it filters ultraviolet rays. After going throughout these last modules, it was 99.99%. The elimination efficiency could be verified in the decontamination of the water, where there was an average of 31 colony forming units for every 100 millimeters. And after the water passed through the system, the average data was 0. The second result is turbidimetry reduction. The system decreased turbidimetry, which is important in safe water quality, in the efficiency of coagulation and filtration processes by removing pathogens, especially those that aggregate in the particles by adsorption processes. During the monitoring phase, the oily water improved the turbidimetry parameters by 98%. This also registered a high color removal by the system. The third result is about pH values. A slight increase in pH is observed in the filtered water, possibly due to the filtered material since pumice and other lysine were used. The data report in both inlet and outlet water were 6.9 and 7.4 pH unit on average, respectively. The fourth result is outlet flow. Regarding the output flow, the system contributed an average of 1.5 liters per minute, keeping this value constant during the monitoring phase. The situation showed that the granular material used did not undergo compaction, which could have caused a plugging of the system, negatively affecting its efficiency. The last result is ultraviolet rays glass effectiveness. The implementation of the glass that generates ultraviolet radiation by means of solar rays required investigated work to create it, because this glass does not currently exist. There are only lamps that vary the radiation, but they control electricity, and our glass does not need it, which is a great benefit. Ultraviolet radiation damages the DNA of microorganisms found in the water. Thank you very much for watching this presentation. Bye.